Topic we are going to see is law of conservation of linear momentum. So already I think you have seen with this and with this definitions. For this, first let us consider with the two particles which are moving equal and opposite forces. So first the particle 1 exerts a force F21 on the particle 2. Same way the particle 2 exerts a force F12 on the particle 1. So from Newton's third law we get F of 21 is equal to minus F of 12. So this we already know from Newton's third law, isn't it? So if you consider the momentum, that momentum can be written as P1 plus P2, which is equal to a constant vector, where P1 plus P2 is said to be what? The total linear momentum. So instead of this P1, P2, it is written as P of total. So we are saying that that is a total linear momentum. Then here the two particle constitutes a system, and so from this we are saying with the law of conservation of linear momentum. So what is the law of conservation of linear momentum is it is given by when there is no external force acting on the body, the total linear momentum is always a constant vector. Just now we have seen that P1 plus P2 is equal to what? Constant. When that P1, P2 is equal to constant, when you are considering the force to be equal to what? Zero. When there is no external forces acting on the system, then the total linear momentum is always a constant. So this is said to be the law of conservation of linear momentum. Okay, so I'll say with the definition once again. If there are no external forces acting on the system, then the total linear momentum of the system is always a constant vector. Yes, so next we have this impulse. So what is an impulse is it is a large force, very large force, which acts on the objects for very short duration. For this, let us consider an example as beating of hammer. Okay, so consider this to be the hammer, and if you beat the hammer, that gives a large force, and that large force is also for what? Very short duration. So only one hit will be there, and with that one hit there is a large force, so that is said to be what? Impulsive force or impulse. Okay, so this is a definition of impulse. It is a very large force which acts on a body for very short duration, then the force is called impulsive force or impulse. Okay, so next we have this F to be the force and the time taken to be del t. We can write it as F into del T is equal to dp, because from Newton's second law. So what is Newton's second law is F is equal to dp by dt. Is it not? So this dp by dt, this dt we are going to bring it to other side. So this becomes as F into dt is equal to dp. Okay, and now we are going to take the limits for this t as well as this p, because we are going to apply the integral on both the sides. So when you take the integral, it becomes integration of dp is equal to, because the first equation we have is what? F into dt is equal to what? Dp, is it not? And so now when you're taking integration on both the sides, we get integration of dp is equal to integration of f into dt. Now apply the limits. Here we are applying the limits to be ti and tf, where Ti denotes the initial time and Tf denotes the final time. Same way here we are writing it as Pi and Pf. Okay, where Pi denotes the initial momentum and Pf denotes the final momentum. Here it is written wrongly. In your book also there is just a printing mistake. It is Pi and Pf. Now if you apply the limits, because this gets cancelled, so if you apply the limits, it is upper limit minus lower limit. Same way here also, f as it is, then upper limit minus lower limit. So we get the equation as this is f of del t. This f we are taking it common, the constant, so we are taking it outside. So integration of tf ti So upper limit minus lower limit. This Tf minus Ti, that is a change in the time taken. So this can be written as del of T. So we are writing this as del of T. And this F into del of T is also equal to what? Pf minus Pi, is not. So that Pf minus Pi is written here as del of P. So this is called as a impulse momentum equation. Okay, so clear with this? So this Tf minus Ti is written as del of T. Pf minus Pi is written as del of P. Yes, clear? Now, this force can be written as the change in the momentum by time taken. So, this is written as F is equal to del P divided by del T. This is the graph which is for constant force. So, when you are considering a constant force, it gives you your straight line. Okay, so this is a diagram for constant force. So just like this, okay? But same thing when you're considering for variable force, we'll be drawing it as in this way. Okay, so this is for variable force. Clear? Next we have the illustration. First one is, let us consider that the cricketer catches the ball. When he catches the ball, what he does is he pulls his hand in the direction of the ball's motion. So we are asking a question, why? So whenever the cricketer catches the ball like this, it's not that he stops in this way, but he takes his hand in the along the motion of the ball. He takes his hand backward, is it not? That is because if he stops his hand soon after catching the ball, so உடனே கை வந்து ஸ்டாப் பண்ணிட்டாங்க அப்படின்னா என்ன ஆகும், the ball comes to rest very quickly. So ball என்ன ஆகும், உடனே ரெஸ்ட்டுக்கு வந்துடும். ஸோ அப்படி ரெஸ்ட் ஆச்சு அப்படின்னா என்ன ஆகும்னா, the momentum is brought to rest very quickly. So அப்படி momentum உடனே ரெஸ்ட்டுக்கு வரும்போது the average force will be very large. Okay, so when the motion of the ball stops very quickly, என்னாகும், மொமெண்டமும் ஃபாஸ்ட்டாக ரெஸ்ட்டுக்கு வந்துடும். ஸோ அப்படி வந்ததுனால ஆவரேஜ் ஃபோர்ஸ் என்னாகும், ஆக்டிங் ஆன் த பாடி வில் பி வெரி லார்ஜ். ஸோ ஃபோர்ஸ் வந்து ரொம்ப லார்ஜ் ஆயிரும். ஸோ ஃபோர்ஸ் லார்ஜ் ஆச்சு அப்படின்னா என்னாகும், இட் ஹர்ட்ஸ் த ஹேண்ட். ஓகே, த ஹேண்ட் வில் கெட் ஹர்ட். ஸோ அதனால தான் என்ன பண்ணுறாங்க, while you are catching, so the hand is taken along the motion of the ball. So அப்படி எடுக்கும்போது the hand will not be hurted. Okay, so this will be asked in 3 marks. Okay, this is one question for 3 mark. So next illustration we have, this is when a car meets with an accident. Okay, and we know very well that nowadays the car has airbags. Airbags are provided in the cars, is it not? So this explains you whether, this explains you why, how this airbag works. Okay, so when a car meets with an accident, what happens is its momentum reduces. So whenever the momentum reduces, what happens, it has a very large force. நம்ம அதுதான் ஃபர்ஸ்ட்டும் பார்த்தோம் இல்லையா? ஸோ அந்த ஃபோர்ஸ்னால என்ன ஆகும்னா, this brings a fatal shock. So to prevent that, what happens, to meet with whenever the car has met with an accident, the momentum will reduce slowly so that the average force acting on it will be very small. Okay, so the average force என்ன ஆயிடும்னா ரொம்ப கம்மியாயிடும். Okay, this is all because of airbags. Okay, so when this airbag is there, what happens, the momentum வந்து ஸ்லோவாக ரெடியூஸ் ஆகும். ஸோ ஸ்லோவாக ரெடியூஸ் ஆச்சுன்னா அந்த ஃபோர்ஸ் வந்து அந்த அளவுக்கு இருக்காது அப்படின்னு சொல்லியிருக்காங்க. ஓகே, ஸோ திஸ் இஸ் அ செகண்ட் illustration which denotes your conservation of momentum. Okay, so here we have the diagram for this. So this is just a picture. When there is a large momentum, this bag produces a small momentum so that the force will be small. Which we have is the shock absorbers which are in the two-wheelers. So that also plays the major role. The shock absorbers in the two-wheelers plays the same role as the airbags. So what it does is, when there is a jump on the road, the force is transferred to the vehicle. So that force is transferred to the vehicle. Then the shock absorbers, what it does, it prolongs the period of transfer of force. So அந்த shock absorbersனால prolong ஆகுறதுனால அந்த force prolong ஆகுது. So because of that, there is no hurt in the driver, okay, or the rider. So rider will not be hurt, okay. So the vehicles without shock absorbers will harm the body due to these reasons, okay. So this is a third example or the third illustration for this law of conservation of momentum, okay. And then we have the last one, which is given as a jumping off concrete wall. So consider two cases. You are first jumping on the concrete wall, concrete cement floor. Then the next is when you're jumping on the sand. Okay. So in these two cases, where you get more hurt, either in the sand or in the cement floor, we get hurted only in the cement floor, is it not? Why? Because is same reason. The sand brings the body to rest slowly than the concrete floor, so that the average force will be lesser, okay. So அந்த sandல என்ன ஆகும்னா அந்த force வந்து கம்மி ஆயிடும், will have the force to be less, so that it will not hurt the body, okay. So this is the, these are all, this four gives your illustrations, okay. Thank you.